Yes, guys. So today I'm taking uh, trigonometric functions of multiple and submultiple of angles. Multiple and submultiples of angles. When angles are halved or maybe makes 4 times or 3 times, whatever. Okay, the trigonometric functions of those angles which are submultiples of multiple angles. Okay, so angle multiple angles or submultiple angles. Their trigonometric ratios or trigonometric functions I have to find out. What are the formulae for them? They are very important. Please, they are the fundamental basics. I mean, they are the basics or fundamentals. We have to understand that so that one can understand how to solve the question then based on these trigonometric functions of multiple and submultiple of angles. Okay, so that let me take them one by one. First of all, question number 1, in which the basic point sine 2a is described, which is 2 sine a into cos a. This formula is very important. I have taken them all of them separately because students have asked me, okay, to discuss them separately so that one can understand how to deal with them, how to use them to solve the trigonometric functions or trigonometric solving. Questions based on trigonometry. All right, so that's why I've taken them separately. Now, some questions also I've taken from, let me take from which question, from 18 onwards or maybe 19 onwards. Find the following, and the value of the following. So 19 onwards I've taken 19 to 21. Okay, in which number of parts are there. I've taken the questions. Okay, and even 18 question is also based on some multiple of angles that I've taken. Okay, up to sine 36 degree. What the formula for sine 36 degree, how to solve it, cos 36 degree, cos 18 degree, sine 18 degree. All these questions we will discuss about, and in detail we will discuss in the next lecture series about all these submultiple of angles. Okay, the trigonometric functions of submultiples of angles. Now let me take these questions. So I'm taking question number 1, how sine 2a equal to 2 sine a cos a. This is basic question we have dealt with number of times. Again, let me discuss this solution here. So we have, let me take left hand side, which is equal to sine 2a. Here it is sine 2a. Now it can be done either directly or first describe what is sine a plus b and then substitute b equal to a, then the solution will be obtained. Okay, or just directly put what is sine a plus a. If I take a and a, there are two angles, two different angles. In place of a, we can take b. Okay, but let me write it as sine a plus a. What is the formula for sine a plus b? In that way, if I describe this sine a into cos a plus cos a into sine a. Now, in place of this second angle, a, we have a here, because a plus a is twice here. But usually we take b, the second angle, a plus b. In that way, this is sine a cos b plus cos a sine b. Okay, so this is the same question because sine a cos a or cos a sine a is the same value. This is twice sine a into cos a. Okay, so this is equal to this 2 sine a cos a. This formula is described this way. Or if I take, since sine a plus b, we know that this is sine a into cos b plus cos a into sine b. Okay, now substituting or putting b is equal to a. Okay, in this equation 1. In equation 1 we get here, this is sine a, or this is sine a plus a. It is sine a plus a, because in place of b we have put here a. Sine a into cos a plus cos a into sine a. That is sine a cos a sine a cos a. This is sine a into cos a plus sine a into cos a. In multiplication, either say a b or b a. Multiplication is commutative. Okay, so a b or b a. So this is cos a sine a or sine a cos a. Both are same thing. This is sine a plus sine a cos a. So this is twice sine a cos a. Either way, we have to deal with this. So sine twice a So sine of 2a is equal to 2 sine a cos a. This has been proved. Now this is proved here. Hence proved. Okay. So this is the first basic or fundamental trigonometric identity or trigonometric formula which we have to remember for always. Okay, this is the basic question here. Now let me take second one and others. Now question number 2. Question number 2 is also of other important trigonometric identity or formula, that is cos 2a. Okay, second is cos 2a, which is okay, this is cos square a minus sine square a. That is the first formula. Let me take, it has 3 formulae or 4, at least 4 formulae there. For sine 2a is also 1 minus 2 sine square a, or 2 cos square a minus 1, or 1 minus tan square a upon 1 plus tan square a. That is also in terms of tan. We will discuss about that. But there are 4 formulae that are taken separately. So all these 4 results, this is cos 2a equal to this, cos 2a equal to this, cos 2a equal to this, and cos 2a, this one, this one. There are 4 results of cos 2a. I'm taking them separately, that I can deal with them. Okay, separately. Or I could solve all those 4 questions at the moment, but let me take one by one. So this is cos square a minus sine square a. Now let me find out that how this is solution. Now here we have cos 2a. Left hand side is equal to cos 2a. Now if I put it as cos 2a, cos 2a means cos a plus a, as we put in previous question. This is cos a plus a. Now if I take a plus a has 2 different angles, what the formula for this? This is nothing but cos a into cos a. Why? Because we know that cos a, cos b minus sin a, sin b. That is the formula. Minus sin a into sin a, because in place of b we have sin a only. The angle is only. This is cos square a minus sin square a. Or this is the same results. This right hand side we have obtained. Or we could say just like this, since cos a plus b is equal to cos a into cos b minus sin a into sin b. Because in case of cos, if it is plus sign, then in between this is minus sign. In case of this result, okay, if it is minus sign, then plus sign. This is the question here. Now putting or substituting, putting b is equal to a in this first result, in equation 1, we get, that means this cos a plus a, that means twice in, simple as cos 2a, a plus a, 2a is equal to cos a into cos a minus sin a into sin a. That means cos square a minus sin square a. This is cos a whole square. This is sin a whole square. Just we write, either write sin a whole square or just write this cos square a. That is also means cos a whole square. Cos square a, because without angle cos has no value in this case. Without angle a, sin has no value. Either say sin a whole square or sin square a. We usually write like this, and this means sin a whole square. Okay, or let me write here, this is cos a whole square minus sin a whole square. That can be written like this, cos square a minus sin square. Hence the result. This is the right hand side. So either prove in this way or the initial way, the first one. Okay, so this is the second question which we have proved here. Okay, so this is question number 2. Now let me talk about question number 3. These are basic fundamental identities of trigonometry. Please remember them. These formulae are very important. They are used usually whenever trigonometry is used. They are usually, explained or written down or remembered. They are used to solve the questions, so please remember them. Now, cos 2a equal to third one. Cos 2a, this is and the result of cos square a minus 1. This is second result of cos 2a. Okay, this is solution. So here left hand side again is equal to cos 2a. So cos 2a, we noted down this is equal to cos square a minus sin square a. This we were knowing from the first result. This is from first equation or question. This is first, not equation, but first question from question 1. This result, sorry, not 1 but 2. This is question number 2. We just dealt with. Okay, so this is the point here. Now if I substitute sin square a as 1 minus cos square a, but we know that since sin square theta plus cos square theta is equal to 1, this is basic fundamental identity, or cos sin square theta is equal to 1 minus cos square theta. In the same way, if I substitute this here in place of sin, it will be cos square a minus 1 minus cos square a, or sin square a is equal to 1 minus cos square a, or sin square theta is equal to 1 minus cos square theta. Now let me solve it. This is cos square a minus 1 plus cos square a. This is equal to 2 cos square a, cos square a plus cos square a twice cos square a minus 1. So hence this is the result in the right hand side here. Okay, so either prove like this, that this we have just proved, or just like cos 2a is cos a plus a as we put in first one, then reach up to this cos a into cos a minus sin a into sin a, and then cos square a minus sin square a. Then sin square a is converted to cos square a from this formula, and then this result is obtained. Okay, so this is the right hand side, hence proved. Or if this question is of higher marks, like 8 marks or 5 marks or 6 marks or whatever, then solve it one by one, just like the second question we solved. In that way we can write cos 2a is cos a plus a, then open the formula cos a minus sin a, because we know that a plus b, cos a plus b is cos a cos b minus sin a sin b. So in that way, in place of b put a, then we will obtain cos square a minus sin square. This is the first result. From this sin square is to be changed into cos square a, that is 1 minus cos square a. Substitute here, then add them after opening this with minus sign, bracket open with minus sign, will be minus 1 plus cos square a. So this is the result. Now go to question number 4 here. Let me take the question number 4. Question number 4 or fourth question. What does it say? It says again cos 2a is equal to, question number 4 is cos 2a. This is the third result of this, equal to 1 minus sin square a. Okay, so again solution. Left hand side, again we take left hand side, equal to cos 2a, which is, if I write cos a plus a, let me take in detail. This is equal to cos a into cos a minus sin a into sin a. That means this is cos square a minus sin square a. Now result is to be taken in sin a only. So convert cos a. Now since cos square theta is equal to 1 minus sin square theta, from first basic fundamental formula, sin square theta plus cos square theta equal to 1. Therefore cos square theta equal to 1 minus sin theta. We substitute this here. This is 1 minus, in place of cos square a, this we have substituted 1 minus sin square a, minus sin square a as it is. It will give us 1 minus sin square a minus sin square a. That means it is equal to 1 minus 2 sin square a. Okay, this is the right hand side here. So convert cos into sin. So the result will be only in sin. In the right hand side, we will have cos square A minus sin square A. So cos square A is converted to sin square A, that is 1 minus sin square A. This is minus sin square, this is minus sin square, they will be added up, which is 1 minus sin square A. Okay, this is the question number 4. Now let us take question number 5. Another important trigonometric identity. All these are trigonometric identities are very important to solve the questions. Now fifth one, tan 2a. Tan 2a is given as 2 tan a upon 1 minus tan square a. Now try to understand. In case of tan 2a, in the denominator we have 1 minus tan square a. But if sin 2a and cos 2a are expressed in terms of tan or tan a, okay, then in the denominator we have 1 plus tan square a. That is the difference to be remembered. So in this case, 1 minus tan square a in case of tan 2a. But in case of sin 2a and cos 2a, if they are expressed in terms of tan a or tan theta, then we write in the denominator as 1 plus tan square theta or tan square a. Okay, that will just express. Okay, let me now first do this solution. Okay, so left hand side is equal to tan 2a. Sorry, tan 2a. That means tan a plus a. Let me write. Now a plus b. What is tan a plus b? Tan a plus tan b upon 1 minus tan a tan b. Since let me write here tan a plus b. Additional formula for this, or some formula for tan. This is equal to tan a plus tan b upon 1 minus tan a into tan b. This is the expression of tan a plus b. So in this way, in this case we have, in place of b we have a. We can write it as tan 2a therefore is tan a plus tan a in the numerator divided by 1 minus tan a into tan a. Okay, so that means twice tan a upon 1 minus tan a into tan a, tan square a, and tan a whole square. This is okay, so this is the same result right hand side. Or if I express tan a plus b equal to this, now put here or substitute b is equal to a angle. Then this will be tan a plus tan a upon 1 minus tan a into tan a. That is what tan a upon 1 minus tan square. Same thing. Since this is there, therefore tan a plus a is tan a plus tan a upon 1 minus tan a into tan a. That is the point here. This is the right hand side. This is question number 5. Okay. Let us take the next. Question number 6. What is the question number 6 here? Now question number 6 is, let me take that. Question number 6. What does it say? It says sin 2a equal to, as I expressed, that if sin 2a is expressed in terms of tan a, this is 2 tan a on 1 minus tan, 1 plus tan square a, as I did tell you. This is the denominator 1 plus tan square a in terms of sin 2a. Right? Sin 2a is 6 question. To tan a upon 1 plus tan square a. This we have to prove. Okay, so let us take this. Sin 2a is what? Let me take left hand side. Let me solve it. Here left hand side is sin 2a. Okay, this is solution we are finding out. Sin 2a. Okay, can be written as sin 2a as sin a plus a again, or sin a into, this is the basic formula of sin a into sin a. Sin a into cos a. Okay, sin a into cos a. That is the formula. Now if I write it as, can be written as 2 sin a into cos a divided by, if I write sin square a plus cos square a, let me write here upon 1. In place of 1 we have written down sin square a plus cos square a. That means this is the formula, basic formula here. Okay, sin a 2 sin A cos A divided by sin square A plus cos square A, because 1 is equal to, since let me write here, sin square theta plus cos square theta is equal to 1. This is the basic formula here of trigonometry. Okay, this is trigonometric identity. So in place of 1 we can substitute here in the denominator sin square A plus cos square A. Now if I divide the numerator and denominator by cos square A, because sin square theta is, or sin theta is sin upon cos, so tan theta is sin theta upon cos theta. That's why I have to divide it by cos theta or cos square A in this case. Dividing this equation, let me take this as the first equation. Now dividing first by cos square A, we get, so therefore in the right hand side only, dividing first right hand side of first, this right hand side, dividing the right hand side, dividing right hand side of first by cos square A, we get only right hand side. So this is sin 2A, we are calculating, will be equal to 2 into sin A into cos A whole divided by cos square A. Numerator is divided by cos square A. Denominator also let me divide by sin cos square A, sin square A upon cos square A plus cos square A upon cos square A. We have divided numerator and denominator by cos square A. So what do we get in the numerator? This 1 cos A cancelled out. It will give us 2 into sin A upon cos A, try for instance. In the denominator, this cos square cancel out, this is 1. Okay, this is 1 here, divided by 1. I have written down this 1 first. Then sin square upon cos square is tan square A. Okay, this is equal to sin A upon cos A in the numerator is tan theta or tan A. So 2 tan A upon 1 plus tan square A. 1 plus tan square is 2 tan A upon 1 plus tan square. This is the right hand side. Okay, so we just started from the sin 2A formula, which is 2 sin A cos A, and dividing by 1, in place of 1 we substitute sin square A plus cos square A, and then divide the numerator denominator by dividing not first right hand side or first, dividing numerator and denominator of right hand side of first, dividing numerator and denominator of first, right hand side of first by cos square A, dividing numerator and denominator separately. That's why we have obtained this question. So this is the right hand side here. What we did, we divide the numerator and denominator by cos square A of equation number 1, right hand side of equation number 1. On the left hand side, so in the left hand side we have sin 2A equal to this. Okay, so that is the result. So this writing, before doing this dividing the numerator and denominator by cos square A, we have write that dividing numerator and denominator of the right hand side of first equation by cos square A, we get this whole. That is the result here. The right hand side is obtained, hence the result. So question number 6 completed. Now let me talk about question number 7. Okay, now question number 7, or we can say that these are the fundamental identities, basic identities in multiple of angles or submultiples of angles, twice A, thrice A, okay, 3 times of angle, 2 times of angle, and half of angle. That we are to discuss. Some multiples means half of angle, 4 times of angle, or triple 3 times of angle, okay, dividing by 3, dividing by 4, dividing by 2. That is some multiples of angles. Okay, now let me take, this is the 6th question we have taken. Now 7th one. In 7th question, cos 2A is to be expressed in terms of 1 minus tan square A in terms of tan upon 1 plus tan square A. I just talked about in the beginning that in case of cos 2A sin 2A, in the denominator we have 1 plus tan square A. That is the point. Okay, so let me take cos 2a, the basic first formula, which is cos square a minus sin square a. That is the basic formula. So let me take solution of this. Solving this now, solution. The left hand side of this is equal to cos 2a, which can be written as cos a plus a, as we expressed, which is cos a into cos a minus sin a into sin a. That is equal to cos square a minus sin square a. This formula we took in second question. From second question up to this we have already done. Okay, now let us take our cos 2a. This is cos 2a. Cos 2a is equal to this cos square a minus sin square a. Okay, now if I divide it by 1, no problem. Let me again divide it. This is cos square a minus sin square a divided by sin square a plus cos square a. Why? Because since sin square theta plus cos square theta is equal to 1. In place of 1 we have substituted. Sorry, this is sin square a. Sin square theta plus cos square theta we know is equal to 1. In place of 1 we have substituted sin square a plus cos square a, because this angle is in a terms of a angle is there. So in the denominator also we have taken the same angle a. Now dividing numerator and denominator of this by cos square a, because we have to take the result in terms of tan theta. So tan theta is sin theta upon cos theta, quotient form. Okay, so now dividing, let me write here properly. Dividing numerator and denominator. This is suppose equation number 1. The numerator and numerator of right hand side of equation 1. This we have to write here. Right hand side means this right hand side. This we have to divide the numerator and denominator by cos square a. So we get on the left hand side we have cos 2 is equal to cos square a. Numerator we are divided by cos square a minus sin square a upon cos square a, dividing by sin square a upon cos square a plus cos square a upon cos square a. What we have done? We are dividing numerator of RHS side by are not written here, by cos square a. Sorry, we have to write here dividing numerator and denominator of equation 1 by cos square a. So dividing by cos square a. This I have not, sorry, I forgot this. Let me write here. Dividing numerator of RHS by RHS of 1 of equation 1 by cos square a. Then we get this, we have to write here cos square a. We have divided the numerator and denominator of this equation 1, the right hand part of 1, by cos square a. We get this. What is this? Cos square a upon cos square a is 1 minus sin square theta upon cos square theta is tan square theta, that means tan square a. Now this is square, sin square a upon cos square a. Sin a upon cos a is tan. This is whole square of tan square a, divided by this is cos square upon cos square a 1, is also 1 here, but this is plus sign, so we can write either first 1 or then tan square theta or tan square theta plus 1 we can write. This is tan square a. This is angle here a. So 1 plus tan square a in the denominator. So this sin square a upon cos square a is tan square a. This is 1 plus tan square a. This is the result which we have to reach here. This is the right hand side, actual right hand side. Hence the right hand side. So proved, or hence proved. Sorry. Hence proved here. This is question number 7. We have completed. Okay, now let us take next question. Okay, now question number 8. Let me check what does it say. Question number 8. Let me further clean it. Okay, now question 8 we have completed. Yeah, sorry, question number 7 we have completed. Question number 7 we have completed. 7th question we have completed. Now let me take question number 8. What does question number 8 say? Okay, let me check it. Right. Question number 8 says sine 3a. We have question number 8. Sine 3a is equal to, we have to prove that this is equal to 3 sine a minus 4 sine cube a minus 4 sine cube a. This is the formula of sine 3. We have to remember this. But how this is resulted into this, that we have to prove sine 3a is equal to this. How? Let me just take it. So, okay, sine 3a, let me take the left hand side, is solution. We have to find out. Solution on left hand side, which is equal to sine 3a. Sine 3a can be written as sine 2a plus a, no problem. Sine 2a. Alright, so this is sine 2a plus a. Now if I open this in terms of sine 2a cos 2a, let me take this. It will be sine 2a into plus a plus b formula. This will be sine 2a into cos a plus cos 2a into sine a. Okay, now we have to express cos 2a in terms of sine only. Okay, the sine formula. So 1 minus 2 sine square a, which is the formula for cos 2a. And sine 2a can be written in terms of 2 sine a into cos a. Sine 2a is this sine 2a. 2 sine a into cos a we know. Into cos a, this is cos a as it is. Plus cos 2a is 1 minus 2 sine square a. I just proved it where? In question number 4. Cos 2a is 1 minus 2 sine square a. This cos 2a we have put here 1 minus 2.